Okay, guys, hopefully you came up with the third side to be the square root of x squared minus 2. Again, with the cosine, remember, when you label your triangle, the adjacent side is square root of 2 and the hypotenuse is x. So any questions on that? So now go ahead and finish it for me. See if you can now, from your triangle setup, look at your outer function, the tangent. See if you can tell me what the tangent of that triangle is going to be. Yeah. So everybody okay on coming up with the square root of x squared minus 2 over the square root of 2? Again, it's the opposite side over the adjacent side of the triangle. Any questions on that one? You guys go ahead and get the triangle set up for problem number 4 for me. Did we come up with the square root of 16 minus x? All right, again, with the sign, remember it's the opposite over the hypotenuse when you label your triangle. Okay? So any questions on using your Pythagorean theorem? So now, go ahead and finish it for me. Tell me what the cotangent of this angle would be. Again, remember, cotangent's reciprocal to tangent. By SOHCAHTOA, what does tangent represent? Tangent represents the opposite over adjacent, so cotangent's going to be what? Adjacent over opposite. So then from your triangle, it's going to be the square root of 16 minus x over square root of x. Okay? So any questions, guys, on, again, it's basically what you had to do last night for homework, those 4 problems, except now, instead of actually getting actual numbers, you have variables as part of your answers. So any questions on those? All right, last thing involving inverses with the triangles is sometimes when you're looking at a composition, you're going to notice on the inside function that you may have operations. And that's why I asked you to pull out your formula sheets. So when you have some composition of functions, you may notice that you have a sum, a difference, and again, sum would be your addition, difference would be your subtraction, or a product, specifically multiplying by the number of 2 as the inner function. So all the inner functions that I've given you so far, it's just been that inverse function. There has been nothing else. There's been no other operations. When you see as the inner function that you've got some operation, an addition sign, a subtraction sign, or multiplication, that's a red flag that you probably need to be referring back to that lovely handy-dandy blue sheet that you got back in Unit 4. This is where your sum and difference formulas are going to come back to haunt you back from Unit 4, as well as the double angles. Remember, on your blue sheet, I will still give you the sum and difference. In other words, you don't have to memorize the sum and difference formulas. I'll still provide those to you. But you do have to know the double angle formulas. All right? You're still going to follow the very similar process we've been doing. You're going to make an equation with the inner function and set it equal to alpha and beta, because that's the variables that you see on your formula sheet. If you see a sum and difference and theta for double angles. You're going to draw still your reference triangles in the appropriate quadrant. You may have to draw more than one triangle, because in the composition and the inner function, you may have more than one trig function representing two different angles. So you may have to set up two triangles instead of one for sum and difference problems. You still will have to find your missing side using your Pythagorean theorem. Depending upon the operation that's happening inside the inner function, you'll have to use your sum difference or double angle formula. And again, you'll simplify your problem by reading your values from the appropriate reference triangles. So let's take a look at example 1 here. Notice you have a composition. Your outer function is cosine. Notice on the inner function, what operation do you see that's happening here? Subtraction. So we have a subtraction sign. So right away, that's a red flag. That is not a product. So you're going to have to use sum or difference formulas. Because it's subtraction, which one do you think it's going to be, your sum or your difference? Difference. So remember, this inverse tangent represents some angle that I'm going to call alpha. You're subtracting another angle, which is coming from the inverse sine of negative 3/5, so I'm going to call that beta. Look at the outer function. The outer function is cosine. So the formula that's going to apply for this particular example is going to be what? Your cosine difference formula. So from your blue sheet, go ahead and copy down what the cosine difference formula is going to be. It's going to be your cosine alpha, cosine beta, plus sine alpha, sine beta. So this is the case where you're going to have to set up two triangles because you have two different angles. You have angle alpha and you have angle beta. So I'm first going to take a look at this inverse tangent of 1/2. So again, I'm going to set up my triangle. This is for my alpha angle. So inverse tangent. Where are you allowed to be for inverse tangent? What quadrants? 1 and 4. Because it's positive 1/2, where am I going to draw my triangle? I'm going to draw it in quadrant 1. So this is my alpha angle. So remember, inverse tangent of 1/2 is telling me that the tangent of alpha is equal to 1/2. So by SOHCAHTOA, what sides of the triangle does the 1/2 represent? It's going to represent your opposite over adjacent. So my opposite side is 1, my adjacent side is 2. How do you find the third side of the triangle? Just like what we've been doing, we're going to have to use what? Pythagorean theorem. So 1 squared plus 2 squared equals c squared. So 1 plus 4 equals c squared. So the hypotenuse is square root 5. So any questions, ladies and gentlemen, on how I labeled the three sides of the triangle? Now, what you're eventually going to have to do, whether you do this now or later, I know eventually from alpha, I'm going to have to replace cosine alpha with the ratio from this particular triangle. I'm going to have to replace sine alpha with the ratio from this triangle. So what I like to do is just go ahead and set up the ratio now. So cosine alpha, cosine represents the adjacent over the hypotenuse, which if I rationalize this, it's going to be 2 square root 5 over 5. Any questions on how I found the cosine of alpha? I'm going to go ahead and find the sine of alpha. By SOHCAHTOA, I know the sine is the opposite over hypotenuse, which is 1 over square root 5. And when I rationalize, multiply top and bottom by square root 5, that'll give me square root of 5 over 5. Whether you set up the sine and cosine now or later, that's up to you. I just like to go ahead and set them up now. Any questions on coming up with the sine or cosine of alpha? Now, you have another triangle to construct because you have a second angle inside this composition. So you now have to set up a triangle for your angle beta. Because you have this minus inverse sign here coming after the subtraction sign. So it's an inverse sign. What quadrant are you allowed to be for inverse sine? 1 and 4. But because it's negative, which quadrant am I going to draw my triangle? 4. So again, this is telling me that the sine of theta is equal to negative 3/5. By SOHCAHTOA, I know sine is the opposite over hypotenuse. Where does the negative sign go? In front of the 3 or in front of the 5? 3. If you remember your Pythagorean triples, you don't need to go ahead and use your Pythagorean theorem because by your Pythagorean triples, what's this adjacent side? 4. If you don't remember the Pythagorean triple, then you have to go ahead and use Pythagorean theorem. Any questions on how I labeled the 3 sides of the triangle? So, because I know eventually I'm going to be plugging them into my cosine difference formula, I'm going to go ahead and set up the sine and cosine from this particular triangle. So the cosine of beta is the adjacent over the hypotenuse, which is 4/5. The sine of beta is negative 3/5. So yes, with the sum and difference, it's going to be more work because you have 2 separate triangles you have to set up. All right, so any questions on how I've labeled or I've set up those 2 different triangles? Now, I can go ahead and plug the values into my formula. I already found the cosine of alpha. Remember, the cosine of alpha is 2 square root 5 over 5. Times. I found the cosine of beta from my beta triangle, which was negative 3/5. Watch your negative signs. Plus. Sine alpha, I set up already from my alpha triangle, which is square root 5 over 5. Sine of beta, yeah, this should be 4/5. You're right, 4/5. This should be negative 3/5. Thank you. I mixed them up. Yep. Because cosine of beta is 4/5, so that's what needs to go there. And then it's going to be your sine of beta, which is negative 3/5. Okay? So any questions on how I plugged into my cosine difference formula? Now we're going back to Unit 4. Remember, you want to multiply before you add. So I'm just going to go ahead and continue this down here. 2 square root 5 over 5 times 4/5. Remember, you're going to multiply straight across. 2 square root 5 times 4 is going to give me 8 square root 5. Over 5 times 5, which is 25. Plus, square root 5 times negative 3 is negative 3 square root 5 over 5 times 5, which is 25. So I luckily already have the common denominator. Can I combine and add those 2 radicals together? Yes, as long as the number underneath the radicals are the same, you can add them or subtract them. You add and subtract the coefficients. So 8 plus negative 3 is going to give me 5 square root 5. And I can divide a 5 out, so it's square root of 5 over 5. Yes, the sum and difference problems, you have 2 triangles to set up and are going to require more work. All right. Any questions on when you have, again, how do you recognize you have to use a sum and difference? You're going to see a plus or minus inside with the inner function. You see that plus or minus on the inside, be ready to use that sum and difference formula. Okay? Let's take a look at example 2. All right. So, ladies and gentlemen, when you look at example 2, this looks a lot like what we already did, what you did last night for homework with one small exception. What's inside this bracket that you did not see last night for homework? You see a what? 2. So right away, that's a red flag that you're going to have to use sum or difference or double angle formulas. Remember, your double angle formula is when you take something and multiply it by 2. That's how you double something. So what's happening here, remember that inverse tangent of negative 5/3, this represents some angle, which I'll call theta. So then what formula am I going to have to use here? I'm going to have to use the sine of 2 times theta. So remember from your blue sheet, the sine double angle formula is 2 sine theta cosine theta. So if you see that 2 inside with the composition, that's a red flag. You're going to have to use the double angle formula. The nice thing about the double angle is you don't have 2 different angles inside. You're just going to simply set up one reference triangle. So unlike the sum and difference where you do 2 separate ones, you only have to do one, because you only have one angle inside. So let's look at that inverse tangent of negative 5/3. So that's telling me that the tangent of theta is equal to negative 5/3. Where for inverse tangent are you allowed to be? You're allowed to be in what 2 quadrants? 1 and 4. Because this is negative, what quadrant am I going to draw my triangle for? Remember, tangent by SOHCAHTOA is the opposite over adjacent. So the numerator is my opposite side, so that's a 5. The denominator is my adjacent side, which is 3. Where does the negative sign go in front of the 5? Is this going to be a 3, 4, 5? Is it a 3, 4, 5? No, I agree. How come it's not a 3, 4, 5? I see the 3 and the 5. How come it's not a 3, 4, 5 setup? What side is always the longest in a right triangle? Hypotenuse. So because the hypotenuse is not 5, don't fall into that trap and label the hypotenuse as 4. So what theorem do we have to use here to find the hypotenuse? We have to use your Pythagorean theorem. So 3 squared is, c squared is equal to 3 squared plus negative 5 squared. So we should end up with square root of 34. So any questions, guys, on how I labeled the triangle? So now what we need to do is plug them into your sine double angle. So again, 2 actually is a fraction over 1. Times. Looking at your triangle, you need to find the sine ratio of this triangle. The sine is the opposite over hypotenuse, which is negative 5 over square root 34. And if you remember back from Unit 4, guys, for the double angles, we did not worry about rationalizing the denominators because we knew with double angles those radicals would take care of themselves in the bottom, unlike the sum and difference. But if you rationalize, that's fine. You'll still get the same answer. Cosine is the adjacent over the hypotenuse. So any questions on how I plugged into my sine double angle formula? Now just multiply straight across. 2 times negative 5 is negative 10. Negative 10 times 3 is negative 30. 1 times square root 34 times square root 34. Those radicals will cancel out like I just mentioned, which will give you just 34. Can you simplify 30 over 34? Yeah, you can divide out a what? 2. So it's going to be negative 15 over 17. So any questions on that? Look at number 3. We're going to change this to a sign, by the way. What formula, ladies and gentlemen? Now look inside, look at your inner function. What operation is happening on the inside? You have a what? What operation? When I say operation, add, subtract, multiply, divide. What's happening inside? Adding. So what formula do you think we're going to have to zero in on? We're going to have to zero in on our what? The sum. Exactly. And which one is it going to be? Look on the outside. What formulas are going to be? The sine, sum. Yep. Yep. I'm not going to give you a cosecant or a secant to do for these. Okay? So, again, this inverse tangent represents an angle. The inverse cotangent represents a different angle. And I'm adding them together, so I know I'm going to be adding alpha plus beta. And when you look at the outer function, remember I changed that to a sine. So any questions on why we're using the sine sum? So again, from your formula sheet, copy down what the formula is. Sine alpha cosine beta plus cosine alpha sine beta. You're going to have to set up your two reference triangles again. So here's my alpha. So they're telling me I've got the inverse tangent of 4/3, which means the tangent of theta is equal to 4/3. So by SOHCAHTOA, what does tangent represent? Tangent represents what sides of the triangle? The opposite over the adjacent. And what quadrant am I drawing this triangle? It's inverse tangent. You're allowed to be in 1 and 4. It's positive, so what quadrant am I drawing it in? 1. So the opposite side is 4. The adjacent side is 3. Now, can I assume that the hypotenuse is 5 here? Yes, it's a 3, 4, 5. So like I did in the last example, I'm just going to go ahead and set up the sine and cosine ratios. Sine is the opposite over hypotenuse. Cosine is the adjacent over hypotenuse. Like I said, whether you set these up now or later, you're going to set them up eventually. I just like to do them after I do the triangle. Any questions on how I set up the first triangle? Second triangle is going to be my beta. They're telling me that the inverse cotangent is 3, which tells me the cotangent of theta is 3 over 1. What two quadrants are you allowed to be in for inverse cotangent? You're allowed to be in 1 and 2. Because it's positive 3, which quadrant am I going to draw it in? 1. Tangent I know is opposite over adjacent. Cotangent is the adjacent over the opposite. So the adjacent side is 3, the opposite side is 1. You guys go ahead and use your Pythagorean theorem and come up with that hypotenuse for me. Did we get square root of 10? Okay. So then the cosine of beta is the adjacent over the hypotenuse. So 3 over square root 10. So when I rationalize that, that's going to give me 3 square root 10 over 10. The sine is the opposite over hypotenuse, which is 1 over square root 10, which will give me square root 10 over 10. Now I have all the pieces that I need to plug into the formula. So I need to find the sine of alpha. Remember, the sine of alpha I found to be 4/5. Cosine beta I found to be 3 square root 10 over 10. Plus cosine alpha I found to be 3/5. Sine of beta I found to be square root of 10 over 10. So now multiply 4 times 3 square root 10 is a 12 square root 10 over 50. 3/5 times square root 10 over 10 is going to give me 3 square root 10 over 50. Can I add those radicals together? Yes. So it's going to be 15 square root 10 over 50. I can divide a 5 out of 15 and a 5 out of 50, so my final answer will be 3 square root 10 over 10. Yes, with the sum and difference, you're going to have two separate triangles to work out. Okay? Yes, Joey? Cosine alpha? Yeah, it's 3/5 right there. Yeah, that's your cosine alpha. Wait a minute. Sine alpha is 4/5. Cosine beta is 3 square root 10 over 10.
Yeah, you didn't do that.
Cosine alpha is 3/5. Sine beta is square root 10 over 10.
Are you saying the 3/5 is cosine alpha? Yeah.
Yeah, because if you look at your triangle, cosine of alpha is 3/5. Yeah, if you miss that up, be careful. That's not pretty. Yeah. Yeah. Okay, so I'm not going to work out the last one, but real quickly here, because I want to talk about courses for next year with the underclassmen. Look at number 4. Tell me what formula you think we would have to use in number 4. Is it going to be a sum and difference? No. Which one is it going to be? Double angle. And which double angle formula is it going to be? Sine, cosine, or tangent? Cosine, because it's on the outside. So the cosine of 2 theta. And remember, you don't have to draw 2 triangles for the cosine. You only draw one for the double angles. Again, your formula, remember, is the cosine squared theta minus sine squared theta from your blue sheets. All right? And then you'd have to draw your triangle and set it up. Okay? All right, like I said,